Have a first-gen Firebird? Not staying cool enough? Want to do an electric fan swap? Don't want to pay a ton of money? Enter the Junkyard Brushless Fan. We're going to keep this thing cool for as cheap as possible, especially if you have a Holley EFI setup. We start off with this Mercedes fan, find our way over to a Volvo fan. It's a long story. You'll see. You'll see, I promise. Point is, it works. You'll just need a bigger alternator. That's all. What's up, guys? I'm Jeremy. Welcome back to Catfish Motorsports. This is my 67 Firebird. And today, we're gonna give a go at swapping this big-ass brushless fan from an early 2000s Mercedes into the Pontiac here. Future Jeremy here real quick. And I just wanna say that as you're watching this, I've had it installed for about 3 weeks now, and it runs absolutely great. Keeps the car right on the thermostat where I want it to be. The only time I've ever seen it get over like 185, 186 is when it's heat soaked, when I've turned the car off and then turned it back on 10 minutes later after I walked into a store or something like that. Now this video is geared towards a first gen Fbody, which there are a lot of people own out there and a lot of people have cooling issues with it. But I do believe that these particular fans, both the Volvo fan and this Mercedes fan that I've got in my hand, would work for a ton of 60s cars and trucks. There's just a lot of radiators from that period that are somewhere in the neighborhood of 16 by 25. And these fans will just flat out work for that range. So no matter what you have, if you're watching this, check your radiator dimensions. Just go to Cold Case and they're really good about putting the core dimensions on there. Check the dimensions of your core. There's a good chance that one of these might work for you. I also want to say that while this Volvo fan has been great, I still think that this Mercedes fan, just by virtue of the fact that it's more centered and you would have more of your fan right behind the radiator instead of, I've got 3-4 inches sticking out over the radiator here. There's no way that this one wouldn't be more efficient. But that just shows you how powerful these are, because that one is running just fine and I never have it going over 60% of its duty cycle. So even without giving it full power when it's like 90 degrees outside, it's keeping me right at the thermostat. And if you're only interested in parts of this video, notably if you want to see how to wire and control a PWM fan with a Terminator X system, I'll put this all in the chapter information so you can jump right to what you need to. Thanks for watching, everybody. Please like and subscribe. Enjoy. Just a touch of background. I've had this car with this setup with the big full-size GM clutch fan in it for about 9 years, and it runs great. I've driven it all over the place, but the caveat is if you get caught in a dead stop traffic, say a drive-through takes longer than you think, especially if it's hot outside, the temperature will creep, and it's never shown any hint that it will settle and stop anywhere. I've seen it get as high as like 215, and I've always chickened out. So while I've probably put 10,000 miles on this car just like it is, and it runs great, that minor cooling issue would keep me from doing something like a power tour. I just wouldn't have the guts to do something like that where I know there's a very high likelihood that I'm going to get caught often in very slow stop and go traffic. And I want it noted here that I am not anti-mechanical fan. One of my most popular other videos is doing a modification to a fan clutch that I have in use on this car here. Mechanical fans are great. Clutch fans, especially those big late 70s GM 19-inch fans, move a ton of air, especially if you do that clutch mod so they come on a little bit earlier. But I just want to try something different. I had this thing laying around and it looks like a good match. Plus, in my case, I have a Terminator X EFI system on here, which has pulse width modulation fan control capability, and I just feel like I'm kind of wasting some of that potential by not at least trying an electric fan, maybe solving my cooling issue, maybe making a little bit more power. Best of both worlds. Now, I picked this guy up on a whim, just sitting in front of somebody's swap meet booth, I think probably 2 years ago, 3 years ago, for $5. Now, full disclosure here, I actually cooked the original one. So this is the original shroud, but the fan and motor assembly was replaced. And I actually got that for free as well. But if you go on eBay and you're not trying to shop around and find the best deal, you can find this exact fan. Search for like a 2005 SL500 for roughly $120 usually. You wait around, I'm sure you can find a better deal, just like I did. Now, the other important thing to note is while the shrouds may change, this Bosch fan motor and blade system, which is about 18.25 inch, about 18.25 inches, came in a ton of vehicles. So this fan here and motor is actually out of a local junkyard. It was in a 2005 Volvo XC90, and it swapped directly in here because this shroud fits better than the Volvo shroud would to this particular radiator. Similar with BMW, you might find for your particular application a different shroud fits better, but you can find this exact brushless Bosch fan motor in all sorts of vehicles. Word of warning, this, I believe, is a 600 watt motor. There is a smaller one. I think they come in 15-inch fans, but they might come in the big fans too. And it's really sort of hard to determine what wattage a Bosch motor is. That information just isn't readily out there, it seems like. So do be careful. But in the real world, I don't think we're going to have to go all the way max power with this anyway. So the 300 watt motor with the big fan blade might be enough. Now, before we really start tearing into this thing, let's talk about a cooling elephant in the room. And if you didn't know there was an elephant here, I'm going to explain to you why there is one. All right, hopefully you guys can see this well. So what's the elephant in the room? The elephant in the room is if you have a 60s or earlier car, especially if you've got a big ass engine swap in that didn't come in there, your car's under radiated. Just almost certainly, bar none, it just is. When compared to even 70s cars, those 60s vehicles are super small frontal square inch area wise with the radiators. OEMs figured out pretty quickly that while you can go deeper and add rows, etc., and that does increase cooling efficiency, it doesn't increase efficiency nearly as much as just making your frontal area larger. Let's demonstrate this. So this right here is the cold case radiator that is in this car. This is the 67 to 69 Camaro or a Firebird big block radiator. So if you had a big block Camaro or if you had a Pontiac engine Firebird, this is the size radiator you would get. Its core dimensions, these are all core numbers, not the total size of the radiator. 16.85 by 23 inches. That's 387.5 square inches of total frontal area. Okay, so that's our baseline. Our second mystery contestant over here is 18.4 by 27.5 for 506 square inches of frontal surface area. That's 30.5% bigger than our 60s muscle car. Any guesses? Well, this is also a Firebird. This is a 70 to 81 Pontiac Firebird. Okay, so just in the decade of the 70s, just fast forwarding a few years from 1967 to 1970, the OEMs realized that, hey, especially with air conditioning and all that stuff, frontal area makes a huge difference. So they increased the size dramatically. Let's make another jump to our next mystery contestant. 17.5 by 34 inches, 595 square inches of surface area. That's 53.5% bigger than this. That one is just a bare bones 2014 Chevy Silverado. Nothing special, just a 5.3 V8 that comes in all sorts of stuff, and it's a full 50% larger than the big block radiator in a 67 Firebird. Last but not least, we've got 15 by 30.5, which is not quite as large. It's 457.5 cubic inches, 18% bigger than our Firebird. What do you think that one is? Well, that, again, is just a basic 2003 Pontiac Grand Prix with a 3800. So with a little bitty 3800 V6, we're still almost 20% larger than we were with the big block radiator. You see what I'm getting at here? Surface area means a lot, because I mean, truly, when is the last time in a newer vehicle outside of a major mechanical failure you remember having an overheating problem? Because I haven't had one in decades. The only time I have has been driving around in old cars. Like, even beater newer vehicles, like my 3rd gen Camaro I had in high school, it never overheated. We sort of fixed that problem with huge surface area radiators, even though they're really skinny. I mean, this radiator right here is about a 1-inch core, but that's all you need because, again, while you can make them wider and that does increase efficiency, it doesn't increase efficiency nearly as much as just making your frontal area bigger. Now, some have it better, some have it worse. So this is a 67 to 70 big block Mustang, and that one is actually almost identical to our big block Fbody here. So if this fan, when we throw it in, works pretty well and fits pretty well on this car, for you guys out here that have 67 to 70 Mustangs, might fit pretty well for you guys too, so maybe something to think about. And our last set of numbers we have down here, 16.5 by 16.85 for a little bitty tiny 278 square inches. That is a 1st gen 64 to 66 289 Mustang. So for you guys with 1st generation Mustangs, you're really in trouble. You don't have a whole lot of core support area to work with at all. You're stuck with a real small radiator unless you want to mod your core support. And maybe there's aftermarket solutions for that. I don't know. This is just quick pulled up off the internet with Cold Case's website. I wrote that one in pink for you guys on purpose. those first gen Mustangs are girls' cars. I don't care what anybody says. So there we are. That's why we're going to try to swap this in, because these dimensions match pretty closely that 24 by 16 radiator that we've got in here. You have a 60s Fbody or a 60s Mustang or any other 60s car probably. You probably have too small of a radiator, but you also probably don't want to hack up your core support to try to throw a bigger radiator in. That's why I'm giving this guy a shot. And this thing should move a ton of air. Now we've said too that the clutch fans move a ton of air. The problem is they're RPM dependent. And most of us need help at idle, not at cruise, which is where this thing is going to shine, because it doesn't care what the RPM of the engine is. As long as it's getting power and I'm controlling the speed, it's going to flow as much air as we need it to. Now, another important warning here, because there have been a lot of failed electric fan swaps on classic muscle cars over the years. And there's a lot of reasons for that. I'm not going to try to cover them all. A lot of times it is just people choose the wrong fans. One of the other big things that happens is, like I said, most of us need help at idle. A lot of times people will find when they do electric fan swaps that their problem flip-flops. They end up doing fine at idle, but then they start having overheating problems when they're going down the road. And that's because a lot of those aluminum shrouds that are super common, number one, they don't have any conical shape to them. That's why I like OEM shrouds. It's subtle, but there is a conical shape to this, which will create a Venturi effect. But they tend to block a lot of flow through the radiator because they're just kind of cookie sheets. That's why you'll see the more expensive units often have flaps. You'll see this on OEM products too a lot of times. They'll often have flaps that will allow airflow through when you're going down the road and you don't really need the fans, so you're not just blocking all that airflow. This doesn't have that, but it's such a big single fan that we shouldn't have any problem with airflow, I don't think. You normally see that issue more with dual fan setups than you would with a big single fan setup. Okay, so we've got a little history lesson in on the size of radiators. We've given a little warning about how some electric fan swaps fail. Let's see if this one's gonna fail. Let me start tearing this thing apart. I used Loctite like a good boy when I installed that, so that was not very fun to get that fan out, but we're out. So here's our replacement fan. It is not just going to drop in without me trimming some of the fat. I knew that, but I just kind of tried anyway. Automatic transmission line in the way, radiator hoses in the way. We are going to have to cut some stuff off of this to hopefully get this in there. And I forgot to say this earlier, but if you were trying this out there in TV land, just like I'm doing here, when I don't necessarily 100% know it's going to work, I'm not losing anything. I kind of already had this. It didn't cost me very much. And if it doesn't work, I'm just going to grab my fan that I already had installed in here and just throw it back in. Doesn't cost me anything with some sweat equity. Not that big of a deal. Now to show you how close I am with this, we're going to test it out with CAD, cardboard assisted design. So this is cut out to roughly the core dimensions of my radiator here. Get you in here so you can see where we're looking at. So here's the inside of our shroud. Here's roughly what my core dimensions are. And as you can see, it is a little too big, especially we've got stuff like this over here, and it's almost kind of got like a double hole design where you get like an extra 3/8 of an inch on either side. We can totally lose that if we have to. We can definitely lose these feet, and we're probably gonna have to lose those feet. And then in the bottom, same thing. We've got some feet here that are meant for mounting. We can shave those off if we need to. No big deal. We're pretty close. It's gonna overlap some. Where I'm really concerned is where the radiator hoses are. So clearly we have our upper radiator hose here. We might have to trim this whole corner off. Same thing at the lower radiator hose on the opposite corner. We might have to trim that whole corner off. And then things like the transmission lines and the petcock, we might have to trim those off. But none of these are insurmountable obstacles. Now, I mentioned that I killed one of these in testing. I actually figured out how to rough wire this when I first got it like 2 years ago. But then I forgot, and when I came back out to do this again, I mixed up the wires. Normally, when I make an error, I am willing to say, hey, I messed that up, especially with a situation like this where I'm just experimenting. I'm not taking the L on this one. Look at this nonsense. So we've got our little PWM wires, which are red and yellow, but then our power and ground are black and beige. Germany, what are you doing? Like, look, I'll go along with the metric system. It's base 10, it's easy, I get it, except for miles an hour. Like, I'm not giving up miles per hour because kilometers per hour just sounds whack. But the rest of it, I'll take. But this is an abomination. Red is power, black is ground. It's not that hard. In this case, beige is ground and black is power. Stupid. And take it from me, because I did it, if you hook it up backwards, you will cook it. Then you're going to be looking for another motor, which is what I did, and that's how I ended up with that Volvo motor. Quick aside on the Volvo wiring versus the Mercedes wiring. So this is actually a head from a BMW. Again, these motors are in everything. BMW and Volvo heads have one of the pins depinned. One of the little guys, so your only little one is your PWM signal. The Mercedes fans, on the other hand, I do believe have all 4 pins pinned. And I think that 4th pin that goes to the red wire is just like full analog. The fan will be on full power, so it's just like an override mode, I think. Maybe a Mercedes guy out there can correct me, but for most of the BMWs and Volvos that I've looked at, there's only 3 pins, power, ground, PWM signal, that's it. All right, now before I start tearing everything apart, I do want to show you how these work roughly and how you can at least test them. Now, this is a brushless fan. That means it requires a pulse width modulation signal, a PWM signal, to make it work. So that's the downside. Unlike a normal electric fan that you can just throw in there, give power and ground and go, this requires an external signal. The benefit is they're more compact, you can control their speed, and they're usually more powerful. Downside is you need an extra box. Now, in my case, I'm going to be able to trigger it with my Terminator X EFI system. They do make external control modules that you can use to control these. You could even get brave and use one of these. This was only 10 bucks. Proform sells one for their fans that they charge 40 for. It looks remarkably like this. You know, you could maybe buy 2 or 3 of these just in case one goes bad. And then if it goes bad, you just grab another one out of your glove box. The downside to trying that with one of these is these are not weatherproof. So this would have to be inside your car. So you'd have to route power inside and then get your PWM signal through that. You couldn't leave this in the engine bay. While your off-the-shelf options from like Lingenfelter aren't going to be cheap, they're going to be about 200 bucks. I am very sure that if you go on YouTube, there's going to be a bunch of people who have figured out budget ways to do this. So that's not what I'm going to be here for, because I'm going to show you how to control it with the Terminator, but I'm going to show you how to test it real quick with one of these. So this is not overly complicated. You got power in and ground in to your box, and you have a PWM signal out. Here is my plug that's going to go into the fan. Now I've just sort of got this rough wired right now. I'll do a better job. Here's my PWM wire, power and ground. Unlike a traditional fan that you would normally run through a relay, you don't have to do that with a brushless fan. You just hardwire your power and ground in. They always have power and ground, and then they just don't come on until you give them that PWM signal to kick on. You can use a relay if you want, if you like the belt and suspenders approach, but even from the factory, a lot of them are just straight hardwired in, power ground all the time. So that's what I'm gonna do here. I've got some ring terminals on here. We're gonna put that on my battery, gonna hook this up to the battery, then we're gonna plug this little guy into the signal. Now, before we get started, most OEM fans, as I understand it, are negative polarity, which I think means they pulse ground. This is something where I wish I was a double E and could explain this a little bit better. When I plug it into this is only giving me a positive signal. Therefore, everything's going to be reversed. So normally, like 100% duty cycle would be max power, 10% would be low speed. It's going to be reversed because it's wanting a negative signal and I'm giving it a positive, I think. Maybe somebody out there can chime in and tell me I'm explaining that poorly, but generally speaking, that's what's going to happen. I know that's going to happen because I've tested this before. Well, I've been off camera beating myself up for a little while. I've sort of calmed down, but I just killed that fan. Remember how I went on that rant about red is power and black is ground and, not to hook it up backwards because you will insta-kill it? Well, when I wired this plug last week to test that fan and make sure it worked with my PWM, with my signal generator, I didn't have proper red and black 10 gauge wire. I have since ordered that. It's here now. But the wire that I had thrown on there just for quick testing, which I was still using right now to show you guys how it worked, was just not the correct color. The red was hooked up to the ground. In the moment when I did it, I knew it. But fast forward a week later, and I forgot about it, and I just grabbed that red wire and said, oh, this is power, and hooked that up to the power, and then hooked the other wire up to ground, and murdered it. 100% stupid, 100% my fault. So maybe take that as a lesson, unless you have a really, really, really good memory that I don't have. Use proper colored wire, because otherwise you'll forget what you did in the moment and you'll kill an electronic component, which is what I did. So we're kind of stuck now. I might go ahead and take that tomorrow and cut it down some and just try to get the shroud to fit. It's Saturday. There is another junkyard that has one of those fans for 60 bucks, so not that big of a deal monetarily, but they don't open till Monday. So I'm sort of stuck for now. So tomorrow we'll come back out here, we'll try to get the shroud to fit, and then on Monday, if I can go get that other fan, we can just swap the blade and motor assembly into our hopefully already adapted fan shroud. We'll see you back tomorrow. I'm gonna try to get this in really quickly because my camera's about to die. So it's Monday, was able to go to a junkyard and get another fan. This is from a 2008 or 9 Volvo, same XC90 that the other one is from. But this one, while the shroud is the same shape, looks like it would fit the same radiator, it is not the same Bosch fan. I'm yet to see if I'm going to be able to transfer it into my Mercedes shroud or not. I might just try to stick with the Volvo fan. Interestingly, the plug is the same. The plug that I had wired up correctly with black and red wires this time does still connect. So this fan, in theory, will still fit an 03 all the way up to like a 2012 XC90, but there's some design differences. Instead of being Bosch, it's got a Volvo stamp on it now, and it does say 600 watts. That kind of confirms the other one was 600 watts. So we've got it connected to my little PWM here. Tried to show it on camera, but you can't see the numbers on camera. I've got it set to 128 hertz, which is almost universal for these fans. And right now I have it set at a 98% duty cycle. This is not a hard rule, but most of the time, above 90 or below 10 is going to be off. It's going to be like diagnostic mode. Now, the weird thing about this one is you can see the fan blade there. That would make you think that's on the inside. But that, I mean, and look at the shape of the shroud. It's funny. I don't want to stick my finger in there because this is powered. But there is a cage here, just like you would expect on the other fans. But it doesn't seem to protect the user from the fan. I'm not sure what that's about, but watch this. I'll turn it on. It's going to come on at 90. So I've got it on 88 right now, and that's pretty low speed. And the air is definitely going that way. It's definitely sucking through the shroud. Now, as I go down in PWM cycle, because this is negative polarity, it's going to get faster. That's 60. And it moves a ton of air. And we have another 50% to go before it would shut off. Going back down. But that's a good tech tip for you guys when you're getting ready to troubleshoot these. If you don't want it to come on automatically, plug this in first before you power up your fan and set it to above 90 or below 10. And that should prevent it from coming on when you don't want it to. Because otherwise you don't really have an on-off switch. So I'm going to play with this thing a little bit off camera and see if it makes sense to try to swap it into the Mercedes shroud, if it'll even fit, or if we're going to move forward with trying to cut this one to make it fit. There's parts of this one that would actually fit better. It's slightly smaller. The problem is when you look at the Mercedes shroud, it's got the piece here that goes across, and we don't have that. So we're kind of missing a shroud piece, but we could maybe fabricate that. And maybe it doesn't matter. All right, here's where we are at. So this is our Mercedes fan. This is our Volvo fan. This is the radiator mounting side of both of these. I know that looks weird on this one. It looks like this should be the back. It's not. I don't know why they did that. I have decided, because this one works and that one I cooked, I'm probably going to go with this. But I'm going to go ahead and cut both shrouds to fit, and then we're going to kind of just look and see what both of them look like, because I can still always get another motor for that and throw it in, and because the plug is the same on both of these, even with this one being a different design, if I decide I don't like the way this one mounts, I can just get a new motor for that one and throw it right in. NBD. The Mercedes fan is a little bit better top to bottom. It's a little bit shorter. This one is a little bit narrower. So this one's better side to side. That one's better top to bottom. And the Mercedes fan, the fan is more centered in the shroud, where it's offset both bottom. See, we've got a bigger lip at the bottom on the Volvo fan. And the Volvo fan isn't dead center in the radiator. We've got a bigger chunk here, smaller chunk here. Now the Volvo fan looks bigger, but it's deceiving because it's got this big chunk of plastic that runs around the top that doesn't do anything. I don't know what it's for other than maybe just mounting up to whatever the top shelf on top of the radiator is in the actual car in an XC90. But we're gonna just snip all that off. We're also gonna snip off all of these brackets that we don't need, anything that's not a rectangle. Now I could, if I wanted to get ambitious, cut off the bottom flush with that, and then we could even take it and, you know, just glue this back on after we shorten it. But I don't think I'm gonna go that route. That's probably a little too ambitious, and I just don't think it's necessary. Similarly, easy for me to say, with the Mercedes fan, it has kind of a dual hull, for lack of a better term, all the way around. And you see I already cut this side off. We're gonna do the same thing to this side, and then with the Mercedes fan especially, but probably with both, where the corners are, that there's a radiator hose, I'm probably going to have to cut those off to make it fit. Because again, this one is a little too wide. That one I might not have to do that to, we'll see. With the Volvo fan, it might make more sense to mount it upside down. That looked kind of good when I had it in there before. If you have a jigsaw, caber saw kind of deal like this, body saw, whatever you want to call it, it makes really quick work of this plastic. So it doesn't really take that long. It's not that much work to just snap that stuff off. Now it is approximately 1,000 degrees outside and about 900% humidity. So it is extraordinarily hot in here. And when I turn a fan on, you can't hear me anymore. So here's what we're gonna do. I'm gonna turn that fan on and I'm gonna start cutting this. I'm just gonna kind of put you guys in fast forward and put some music in the background. Sound like a deal? Deal. Okay, so here's our Volvo fan. Now, side to side, we're actually pretty good. It's resting on top of the lower radiator hose over here on the passenger side of the car. So we're gonna have to notch that area. And that would allow us to come down another 1.5 to 2 inches. Now, the way this is designed, because this is elevated in the shroud rather than being kind of more centered like the Mercedes fan is, you are going to have a hump at the top or at the bottom if you decide to put it upside down, one of the two. The Mercedes would have that too, and the factory shroud has a hump at the top. So that's really not that out of place, but this one is more than I would like it to be. I do think I like the shape of the Mercedes fan better. It's just gonna require more trimming because it's wider side to side, which gets you more in trouble with your radiator hoses. Now, if you guys have a manual and don't have transmission lines like I do, you're probably gonna have a little bit easier a time than this. Let's throw the other one in there and see how close it is. I suspect we're gonna have to do more trimming to it. Now, I should note too, that both of those fans are about 4 inches deep, whereas I have about 5 inches from the radiator core to my front of my water pump pulley here, which is why the super common Lincoln Mark 8 fan that you can still get made by Dorman will not fit in these cars because they're like 6¼ inches deep. Now, if you've got a small block Chevrolet in a first-gen Camaro as opposed to a Firebird, you might be able to get it in, but if you've got a big block or if you've got a Pontiac like mine, it's just not gonna work, and that's where you're gonna have to start looking for a shorter fan assembly. All right, Mercedes fan going in. That trimming off that dual hull thing helped. Definitely more shimmying going down. And yeah, we're definitely getting more into this tube here, which is pushing us over into the transmission lines and stuff. So I can't quite go in straight like I could with the other one, but we're close there. So you see we've kind of got the same issue, but that's just because we're resting on that fan. But because this one isn't raised as much, when I notch this one out, it is actually going to fit better. So let's do that. Okay, so this is the Mercedes fan after I notched for the lower radiator hose on this side and a little bit for the drain plug on this side. And boy, that is damn close to being like it's made for it, isn't it? You know, obviously we're overhanging the core a little bit on the sides. It's a bit more so on the passenger side than the driver's side. But we can just put a little bit of, you know, weather strip in here, just rubber weather strip to seal this all up. And that is damn close. All right, let's try the other one. There's pretty good too. Now, again, this is the one where I probably could snip an inch off the bottom, but I don't really think it would gain us that much. So we're gonna go ahead and roll with this one for now because this fan is functional. I'm gonna make a couple of modifications to it, and then we're gonna just kind of quick mount it. I'm not gonna go crazy with it because I might ultimately end up going with that other one. And then I'll try to figure out how to set this up with my Terminator X system, which I've never done before, so that'll be fun. I've got the fan in the car. It's just kind of zip tied up right now, but I have confirmed that it will work. I've got my laptop up here. I've had my additional input output plug plugged in. Now I am going to depin this because I'm only using the one wire, but you need a Metra Pack tool, which I don't have. So I've got one of those on order and we will clean this up. But for now, I've just got it rolled up. When it comes to wiring these, specifically with the Terminator X, Holley's a bit weird about it in their instructions. In their instructions, they include a pin map for an 8-pin connector. And then there's just a little line that says you may only have a 3-pin connector. So I'm guessing maybe the 8-pin is for like common to LSs, and maybe that's why it's the default in the instruction manual. But I only have the 3-pack, and I had to go through a bunch of stuff to figure out what the pin map on this was. But I finally figured it out. There's kind of 2 sheets that are relevant. I will post them both up. And we are using this green stripe gray wire. Another interesting note, Scott over at EFI Systems Pro told me about this. If it's gray, when we're talking about Holley, it's an output wire. So whiter input, grayer output. So if you're not kind of sure what it is, gray is going to be output. So ours on this one, on our additional input output plug, is C. That's the one we're using. But C translates to pin B3 on our input output map when we switch over, and I'll show you the computer. And there was a couple of guys that I watched YouTube videos of that had some really quick, good explanations for how to program the PWM, but they didn't really talk a whole lot about wiring it. So I'm going to hopefully try to help you out with that a little bit. It's not hard, but we're going to try to get it all in one package instead of you having to find multiple videos. Okay. So if we look way back here, now it depends on how you have your wiring hidden, but there will be, at least on mine, a three-prong plug. If you have the different type, it might be 8. But it says input, output on it. That is your harness for additional inputs and outputs. Now, I had not been previously using any of them, and it looks like on this, it's all gray wire, so these are all going to be outputs. In theory, there are ways that you could do this directly to your J1 plug 2 that plugs into your ECU. But we're going to use the harness for this in the meantime. So I'm going to plug this in. There we go. Okay, so that's plugged in now. We'll hide these wires back here in the meantime. Now, I've got all this still strung way out. These are like 10 feet long, same thing with this. But that was just so I could test it, which I will show you now. Got this thing set up right now just for testing purposes to just come on as soon as I turn on the key. A lot of times you'll do an input trigger, so it would only engage if it's sensing engine RPM, so it's not coming on for no reason. So as soon as I turn the key, it should come on. There we go, and it's a soft start. So there we go, fan's on. It's on low speed right now. Let's get this so we can show it's pulling air through. There you go, look at that. Also may or not be able to see, I've got a piece of clear plastic in here that's sealing this to the shroud now, and I've kind of got some poorly put in weather stripping in there. It was just all I had laying around. I've ordered some better stuff that will fill a bigger gap and hopefully go on a little cleaner. But in the meantime, this was enough, and this is enough to seal off the radiator. You're probably gonna be able to see that. I'll have to show screen. But I have this set up to where it comes on at 75 degrees of coolant temperature sensor, because that's just what it is ambient right now. So I'm going to change this from 20 to 40, and you should hear it go up. Now, this is an important distinction, because remember when we had it plugged into our little handheld system and the polarity was inversed because it was negative? Now that we're sending it a proper negative PWM signal like I want, a jump from 20 to 40 is going to be faster rather than slower. So we're going to change this to 40 and hopefully you'll hear it speed up. Hear the change in pitch? That's the fan speeding up. And I'll go over all of this a little bit more in depth with kind of a zoom in on the screen, just kind of sharing screen. It's hard to do on camera while you're doing it real time, but I will show you how to set this up properly.
All right, so here we go. And this is pretty easy. I've just got an old file loaded, so this is not what I've already set up with my fan. So the first thing we need to do is set our input output. Now, if you've already done this before, it might already be here. It'll say IO. If not, you're gonna go to Toolbox, add individual config, go down to IO, default IO, open. Now you've got that. So we're gonna hit that. Now we're concerned with an output. So I don't have any on this file. You probably don't either. We're gonna go and just name it something, it doesn't matter. Call it PWM Fan. And I think you have to hit enable before it'll let you do anything else. We're gonna do that, type PWM negative. Even though the page said that we could do PWM positive, it doesn't seem like you can with the Terminator X. You probably can with one of those ones that have 8 pins. So like a Holley HP or something like that, you probably could. Just hit OK on that. And then we're gonna hit configure. Switch to input trigger, we're gonna leave as none. Sensor input trigger, this is the one where we said you can set it up so it only activates when your engine RPM is active. So we'll say engine RPM, or just RPM, is above, let's call it 500. So now the fan's not going to come on until your engine is actually started. You don't have to do that, but you probably will. PWM setup. Okay, there's a couple of important things here. Number one, we're going to go to fixed. Frequency. This is easy to forget, but remember I said most fans operate right around 128. So that's your good starting point, especially if you don't know exactly what it is. Some of them are 100, some of them are more. Some of them are different, but 128 is a pretty good starting point. Most of them are going to work at that. Table units, we're going to go to duty cycle, because remember we're in percentage of cycle here. And then your X and Y you can kind of set. Let's set our Y first. We'll set that to coolant temperature sensor, CTS. And then our X, you can kind of make it whatever you want really, because we're not really triggering based on that. We're going to have the whole line. So it really doesn't matter. I've seen people do RPM, so we'll just do that for now, but it really doesn't matter. All right, so let's have a reasonable number to start here. We'll say 120. And then our top one, we're gonna say 210. And then that auto fills in between. Now you can play with these numbers to get kind of your exact points you want. For us, for right now, this will work. Now remember, your bottom line has to be 0. If it's not, your fan is going to come on as soon as you turn on the Terminator X system. So we're going to leave the bottom line 0. Now I have a 180-degree thermostat, so I don't really want my fan to come on, too early anyway. So we'll leave the first couple lines in this instance at 0, and then we will say at 152 we want it to be 20. I'm going to make that whole line. So now below 152 we're 0. At 152, we're 20. Now where you want it to start to kick up is up to you. And you can play with this stuff as you find out what your car likes and what it doesn't. But we're gonna say for ours, we're gonna make it also 20 up until 175. And then from 175 to 178, which is still below my thermostat, we want it to be 40. We're starting to ramp up here. In here between 182 and 189, which is generally where my thermostat's going to function, we're going to say we want that to be, 50% duty cycle. And you can just kind of see where this is going. Again, you can do whatever you want here, whatever makes sense to you and your car and your thermostat. But at the end of the day, it's going to look something like this. So now our PWM is all set up. We need to set up our pin map. Go up here to pin map. Now remember, we said that we are B3. It starts you out on inputs, click output, B3. So we created our output called PWM Fan, and that is unassigned. So we're just gonna grab that and drag it down to B3 here. So now that output is assigned. You can hit done. And now you can save your file. I'm gonna save as, so I know that I've edited it. We're gonna call it Firebird 91025. And you're done. You now upload that global file to your Terminator and you're good to go. Your fan should function now.
All right, so here's the deal. Fan is on. It's sealed up from the bottom. Use some aluminized tape for that. I have had the car out here running just to get it sort of up to temperature. I did have to go in and make one change to our previous program that I'll show you. The bottom line has to be 0. We had the bottom line as 20. So as soon as it sensed RPM, it was on. If your bottom line isn't 0, it's going to come on as soon as you have whatever trigger you have tells it to come on. So our bottom line was changed to 0. Then it goes to 20% at about 160 degrees, bumps up to 40, up to about our thermostat temperature at 180, at 181 or 182, somewhere in there. It's supposed to go to 60. I've had a hard time getting it to that 180 number. It settles in with the fan at a 40% duty cycle at about 178, 179, and just won't go anywhere. Right now, sitting here letting it get heat soaked, it's like 161. So I'm going to turn it on and we'll show you guys that the fan comes on, and we'll show you guys that it's just not really going anywhere. I'm going to take the car around the block. I don't trust it going super far with it just zip tied up. It's not hard mounted anywhere, but I think I can go around the block without it falling off. Oh, and if it sounds like it's knocking, it's not. It just has loud valves. It sounded like that for 10 years. If it was knocking, it would have blown up by now. So this doesn't want to focus great, but we can see that we're at 163 coolant temperature. Just sitting here idling at about 850. There we go. 164 coolant temperature, idling about 850. It'll probably get up to about 178, 179, and that's as far as it's going to go. We can see that our fan is on. At least I hope you can see that. Our little clear panel here, you really can't see it, but the fan's on. I can feel it pulling air through, and you know, it's just not working very hard right now. It's at less than half of its duty cycle, and it just sort of holds temperature. I mean, even though this shroud comes up a little higher than I want it to, the other one would be slightly a better fit top to bottom. Doesn't seem to matter. This one seems like it's going to work just fine, and this one's easier to fit side to side. I really only had to make one cut on the side just for the lower radiator hose. So we're at 178 right now. We'll let it sit here and idle for a little bit and see if it gets any higher. And it's still hot outside. It's still 85 degrees and 1,000,000% humidity. We're actually falling. We've gone from 178 to 176. All right, so I'm gonna take it for a test drive. I'm just gonna run around the block because, like I said earlier to you guys, sometimes when people go to electric fan setups, they end up with the reverse problem. All of a sudden their car stays cool at idle but gets hot when you're cruising down the road. So I'm gonna see if it does that. We'll be right back. All right, we're back. That went really well. It got up to 182 max. Only problem I had was I noticed that I wasn't seeing my kind of 13.8, 14 volts that I normally see charging, and it actually dipped down into the yellow on my heads up display. So that's interesting. It's possible during all my testing and stuff that I nuked my alternator accidentally. It's also possible we need an alternator upgrade to use this PWM fan. Now, I made a little saddle mount here. I'm gonna make one for the other side. Remember, this channel is hollow. You can drill into this. Now, you can drill into it from the top, but you have to be really careful when you do that because you could potentially lose control of your drill, go through, hit one of your tubes, then you're in trouble. It's safer to go in from the side. All right, it is the next day. We've confirmed our fan works. I charged the battery overnight, went for a ride today. It is as hot as can be outside, and it still stayed cool. Downside. We've definitely confirmed that the alternator is charging. If I test it at the back of the alternator, I'm getting 14 volts. However, it is not putting out enough amperage at low speeds, at idle and low speed cruise, to keep up with the fan once it kicks up to like the 60 duty cycle rating. I really thought I had a 94 amp alternator installed in this, but that was incorrect. So I found the box because I exchanged this for warranty one time before. This is a 78 amp alternator. It's a 12 SI normal 3-wire setup. And I'm almost positive that when I bought this, it was 94. And when I exchanged it, I think they gave me a 78. And I just didn't notice because the part number is 72739A. And I think I thought that 9 meant 90 amps. And that is not the case. The one that's 94 amps is a 3A. So we're not going to do that here in this video, but this car is going to have to get an alternator upgrade to handle this fan. If you guys are switching to any kind of high wattage fan, if you have less than a 90 amp alternator, it's not going to be enough. Especially if you're watching this video because you already have a Terminator X and you wanted to see how to wire that up. The Terminator X plus a radio plus this fan, you just need more amperage.
I actually ended up buying this Mr. Gasket 140 amp alternator that was on a crazy sale for almost $100 off when I bought it. But I found that I was actually still having low voltage issues with the fan on even when I installed this alternator. What I ended up having to do was going back and going to a much more aggressive 8-gauge charging cable from the back of the alternator as opposed to like the factory setup, which was a 10, maybe even a 12. I went to the thicker charge wire. My voltage issues got a lot better. If you have a 78 amp alternator, it's probably not enough. But if you have a 94 amp alternator, before you go upgrading your alternator, try upgrading your charge wire. It might solve your issues before you spend any money.
But that's going to do it. This was absolutely mission successful, even though we found out we need a little bit of follow-on maintenance. If you have a first-gen Firebird or any old hot rod from the 60s that's under-radiated like we talked about earlier and just needs a little bit of help, these junkyard fans will work. I went with the one from a Volvo. The one from the Mercedes we showed will work too. It might even look better. And they put those Bosch fans in BMWs, Volvos, Mercedes. There's lots of junkyard options out there. I would just tend to buy the ones from the bigger ones, like an SL500 instead of like a C230, because the C230 might only have like a 300 watt fan. So buy one from a bigger model. This really wasn't that bad, and now that I've shown you how to wire them and not burn them up, you should have a much easier time than even I did. As always, please like and subscribe. If you have any questions, drop them down below. I'll help as best I can. We'll see you next time.